Hey everyone, welcome to the Latent Space podcast. This is Alessio, founder of Kernel Labs, and I'm joined by Swix, editor of Latent Space.
Hello, and we're so excited to have Kyle finally in the studio. Welcome.
Hey, I'm very excited to be here.
Kyle, you're CEO, founder? Co-founder?
Co-founder, CEO, yeah.
Of OpenPipe, which started 2 years ago and recently got acquired by CoreWeave. Congrats.
Thanks.
Where I think you might be our first started and exited founder that we've had on the pod. Maybe-ish. I don't know. I'm not keeping
especially on that timeline.
Well, I don't think I was exited when I don't remember if we set this up before or after we announced we were getting acquired.
I specifically pinged you because you got acquired. You've been on my list to watch. Obviously, you've spoken 3 times at AIE. And you've been on my list of when is it a good time to have an OpenPipe or fine-tuning RL discussion? And then you got acquired, and I'm like, okay, yeah, that's a good time to talk about it. Also because I think it gives us a window to talk about acquisitions, consolidation, what should be an independent company, what maybe doesn't have to be. Anyway, but we'll maybe do this chronologically so we don't get too far ahead of ourselves. You were famously director of startup school.
Yes.
Maybe for people who don't know, what is startup school? Did that make you fall in love with the color orange?
Yes, I'm wearing an orange shirt for those who are listening. A very bright orange shirt. This is my conference shirt, and I felt like it was appropriate for the pod as well. So yes, I was at Y Combinator for about 4.5 years and led the startup school team there. So startup school, it's changed over the years. It meant one thing before I was there. It means another thing now. But during the time I was at YC, startup school was basically all of the external facing, a lot of the content, certainly all of the tech. So it was things like we had a MOOC effectively where founders could come in, they could learn about how to start a company, they could get advice from YC founders, YC partners. We had a co-founder matching service that we built, which actually worked really well. We got a lot of people through. Our total, I guess technically I can't, that probably doesn't matter anymore, but a very large fraction of the batches that went through YC while I was there were directly attributable to people that we found and ended up recruiting to YC through their experience at startup school. So that was kind of what we were working on.
Yeah, I always kind of consider it as the scout program for YC.
Yep.
Right, the YC before totally. The YC. Any notable famous people that met as part of your co-founder matching? Because I'm always very negative on those things because it's like online dating. The chances of success is super low.
Yeah.
But when it works, it's really nice.
That's a great question. I left, so we launched that product probably 9 months before I left. And so I don't know what the long-term outcomes were of that specifically.
Yeah. So you left YC. You spent a year in the wilderness. You went through YC S23. Mm-hmm. What's that journey like? What's the...
I was very excited about AI things in general. So I left YC, I guess, beginning of 2022. And I was trying out a bunch of different things. Ended up landing on what turned into OpenPipe in early 2023. This was, let's see. So I'd been working. So my co-founder is my brother, my little brother, which has been a fun journey on its own. We were looking at different ideas. And one thing we realized was we actually started the company immediately after the GPT-4 launch. And what we saw as the opportunity in the market at the time, which has changed since then, was GPT-4 was insanely expensive and extremely powerful. But there was an opportunity to distill specific workflows from GPT-4 down to much smaller, much cheaper models. And there was a very clear value prop there, given how expensive GPT-4 was. It was hard to deploy in production, but you could sort of take those abilities and deploy them much more cheaply. So that was kind of the first thing we built, was this kind of very managed, very clean distillation flow.
What was that process like in the beginning to get people to actually care? Because I'm assuming most people are doing experimentation, but didn't really have these large production workflows that they needed to distill down. Mm-hmm. And then I think maybe once we got there, the models get cheaper and faster. So what was the initial, 6-9 months of the company through the evolution of the models?
Yeah, so it worked. It was great. So, it did take us a while. I guess we formed the company early, maybe March of 2023. By the time we launched our product, it was August, I want to say. There were some different things we were trying in between. And actually, it was not hard to find people and get them excited. There weren't very many. This was even late 2023. There weren't very many people in production, but anyone who did have production workflows, it was extremely painful. They were paying hundreds of thousands of dollars a month to OpenAI. So it was very easy to convince them to try this out. And so we got our first 3 customers after launching, probably within a month. And we were doing significant revenue. Over the next 6 months, we actually got to $1 million in ARR over about a 8-month period following that launch. So by the latter part of 2024. So actually, yes, initial traction was super strong, very clear value prop. But then, as you were alluding to, kind of like there was just this slow march of like the frontier model token prices just dropping over and over by 3-5x over and over again, which kind of ate away at our value prop over time.
What was the process of like fine tuning the model? Because even the open models were not that great, And so, what were maybe the bottlenecks? Like instead of having 3 to get to like 30 customers, did you feel like in the beginning it was like a matter of like just the market growing, like the open source models not being good enough, like the fine tuning not being simple, efficient enough?
The pain point, I guess, repeating what I said before, was the price was too high on the closed models, but you couldn't just drop in an open model and replace them because, like you're saying, the quality was quite bad, especially as you're moving to smaller model sizes, but larger models, open models weren't even available at that time. So that's kind of where the value prop was like, hey, the closed models are too expensive, at least the ones that are performant enough to do the job. The open ones are not good enough. We have like a very clear managed flow. The way the flow worked was quite simple. You simply put in our SDK. It's a drop-in replacement for the OpenAI SDK. It's capturing, you continue to use GPT-4 in production for a period of time. We're capturing the requests and responses. And then we had just a very clean managed flow where it's like, okay, at some point you say, hey, I want to distill this down, and you train on that. And then, we provided an API that was a direct drop-in replacement. You would just change kind of the inference URL, and you were using your own model, and your app continued working.
Yeah, I think the market analysis here, because I was also exploring starting a business around that at the time, and that's why I ended up not investing, was basically you get squeezed between the GPU providers who also want to do fine-tuning as a service, because then that makes people more sticky, and the labs who keep putting out distilled versions of like something, whatever mini versions of their models. What was the analysis on the neo cloud side? Because you kind of also want to host the inference.
Yeah. Honestly, we like I was saying, felt very squeezed from the frontier labs that were putting out just more capable models at lower costs. I did not see the competition ever really materialize from the neo clouds, from the GPU providers. Everybody had an offering in fine tuning. When we talked to customers, nobody used them because they just were really hard to use. So I do think that, like, call it a product thing, I guess.
Like, it's not their focus. So
yeah.
Who cares? Yeah. Interesting. Developer experience matters.
It does. Yeah, it still does. I don't know. Maybe it doesn't matter anymore. Now we just have coding models do everything for us.
No, it still does. Like when you have thinking machines launching an API and people getting excited about the API, you're like, yeah, okay, that's pure developer experience there.
That's fair. Yeah.
Yeah.
I'm just going through the chronological list here. Yeah, was like the Mistral 7B fine tune kind of like one of the big inflection points like in the history of the company? It's like, okay, this is like a good open model and like the 7B size, or is that just
Mistral and Mixtral? That was like a golden period of fine tuning startups, because Mistral was like a credible open source model.
Yeah, they were really strong models, better than the Llama 2 that they were effectively replacing, and they also had a super open license, which I think the licensing has become maybe less of a concern over time at the margin because people are getting used to maybe. But at the time, that was like a pretty big deal that they had this fully open Apache 2 license. And, maybe they have their own like IP issues with how they trained it. I don't know. I have no inside information there. But at least the guarantee they were making to people using their model is,
I call this Mistral washing. As long as it's like it's comes from the sparkling region of France called Mistral, it's okay. Don't ask about what goes into it.
There's plausible deniability, arm's length connection there. Yeah.
Okay, there was this Mistral period. Jan 2024, you talked about LoRA, and there was a period of time where LoRAs became more important. I feel like they then became less important. And I don't know what's like the rise and fall of LoRAs for you as a business.
Yeah, so LoRAs have really, so if you're predicated on the fact that you're doing fine tuning at all, LoRAs have very, very attractive properties relative to doing a full fine tune, right? Because if you're doing a LoRA, you can add training time. It helps some. You're using less memory to train, but where it really helps you out is at inference time. Because if you're doing LoRAs, then when you deploy it for inference, you can multiplex, basically an arbitrarily large number of LoRAs on the same GPU deployment. That lets you do things like do per token pricing as opposed to GPU hour pricing. It just gives you much more flexibility at deployment time. I'm actually still a LoRa bull, like for the record. You're talking about the rise and fall. I think LoRa's, their future is still out there.
I mean, they're cool again because thinking machines.
Yeah, and I felt very vindicated by that blog post, for the record. Just, I guess, for listeners, Thinking Machines put out like a week or two ago a blog post doing quite a lot of research on the trade-offs between LoRAs and full fine-tuning in various different training regimes. I think the reason LoRAs were uncool for a while was mostly just because like fine-tuning was uncool. Like I think if you're doing fine-tuning anyway, like LoRAs are still like, in many cases, the way you want to do it. But not that many people were doing fine-tuning.
As a marketing guy, LoRAs had bad marketing. Like they were just like, oh, like you can't afford full fine-tuning. Here's like the Walmart like store brand fine-tuning.
No, that's fair. There is some of that. I think we didn't have a huge issue. Like we've had to do some user education, like, hey, just try it. I think for the training runs that, like the types of training runs that we're interested in, where it's like, hey, I'm doing a relatively lightweight customization of an existing model for a specific task, there's really no downside to using a LoRA. And there's a lot of like upsides from an like infra simplicity point of view. I agree that there's like a branding issue around that. Hopefully the Thinking Machines blog post kind of addresses that.
Rank one. And I think there's different hyperparameters, the LoRAs that you can use to make yourself happy. The fact that John Schulman was like, no, like we're actually banking the company on this, at least for now, is a pretty big vote of confidence. I feel I think it's surprising that no one's done the research prior to them.
And I was talking to someone at Thinking Machines prior to their launch who had come from one of the big labs, and what that research told was like, oh no, everyone doing post-training research inside this big lab uses LoRAs. I mean, not for like the full run, but like when they're doing like their experiments, they'll just use LoRAs on a base model to run the experiments, and it works fine.
For listeners of the pod, that was leaked in one of the pods that we released, but it's up to you to find it. Cool. And then it was the first World's Fair. You talked about you probably don't need fine tuning as a fine tuning founder. Basically, I think your talks are really good. I would recommend people watch all of them. What I pulled out was you had a piece of advice. So your talk title was obviously somewhat intentionally clickbaity, but your actual advice on when people should fine tune is when it's cost, latency, or quality consistency that you really care about.
Yeah, I mostly stand by that. I don't think it's changed. And the biggest one we see today, and this is true for kind of like classical SFT, it's also true for the RL stuff we're doing today. Crossing my fingers, it's not always the thing. But the main one I see that really drives fine-tuning is if you have to move to a smaller model, and it's typically for latency reasons, and this is usually like real-time voice. So if you're sort of forced into a smaller model anyway, then there's a very high chance that doing some tuning on that model is going to get you, like it will be necessary basically to have a successful deployment. So we see that a lot coming from customers that, again, have those latency requirements. There's other reasons as well. Sometimes, for whatever reason, you really have to deploy on a single GPU. You have to deploy within your own cloud, and you want you basically have to use a smaller model to do that. So basically, in the case where you're forced to a smaller model anyway, then fine-tuning it is often necessary. I would say for 90% of use cases where you aren't forced to a smaller model, then it's still not a good ROI, and you probably shouldn't invest in it today.
How do you quantify these things? So costs, right, could always be lower. So is there kind of like a threshold of like cost to ROI? Like, because it's also hard to figure out how much it's going to cost to do the fine tune, because you need to get the data and all of that. Like, do you have a mental model of that?
This is sort of like a function of the total amount of overhead required. I'd say there's two parts on the cost side, and then there's multiple parts on the benefit side. On the cost side, the main things you have to think about are the upfront effort required to get an actual like training system set up for your task. And that can be quite variable, but I would say at a minimum, you're going to have to dedicate a couple of weeks of like a fairly competent engineer's time. And if you have like a very complex system and you're doing RL and you need to set up a whole environment, it could be a lot longer. It could be, a couple of months of time. So that's just like a fixed cost you have to pay. There's also like an ongoing carrying cost where once you've committed to doing fine tuning, it does make other parts of your stack less flexible, less nimble, because whenever you're updating your prompt or like you're adding new context or whatever, like now you have to like, spend a few hours training a model, and that's just going to like slow down your iteration cycle, which is a real cost. And in many cases, that's the larger cost. So you only want to do that if like the benefits are large enough. The dollar cost, I would say, is basically never a factor. It's just so much less than the amount you're spending this engineer to do the work that it's not. I mean, it's each of these runs is between $5 and a couple $100, and it's just you don't have to do that many of them.
Yeah, because most of the data is like first party.
Yeah.
Right. Okay. When was the switch to RL? Was it when O1 preview came out, you were maybe like, okay, it's time to move on from SFT, or?
Yeah, so that was a big moment for us with, there's all the leaks before that about Strawberry and all this. And like, a lot of people talking about, okay, how are they doing it? We realized through that like, okay, someone's figured out how to make RL actually work with LLMs, which was not a thing. I mean, it was a thing that like some people had played around with before that, but it wasn't like a thing many people were thinking about. And so our bet at that point was, yes, let's figure out whether this works for task specific thing. And the space we just, I think it's important to kind of like tease out different parts of the market. I think with the release of O1, and this has been like proved out many times with releases since then, I think like there's now like a very strong consensus that like, okay, on the frontier model, like general purpose model side, investments in RL are paying off. I think that I don't think most people would argue with that. Especially as you're getting into these agentic tasks and training them to do that, like it seems very clear. Well, obviously the big labs are paying like ridiculous amounts of money for these environments and everything, but also like they're actually getting really good results. The models coming out, we're seeing it especially on the coding model side, but like in other contexts as well, we're seeing the sort of especially agentic use is working way better because of this. So I think like even late 2024, it was pretty clear that like RL was going to work in that context. And then the question in our mind was like, can we apply this in a different segment of the business, which is kind of like task-specific customization? And so the question is like, does that work well? How much effort does that take? Is it going to be something that ends up being unnecessary because, the big labs can just like train on every single task and the base models are going to be just good at everything. And so there's no benefit to it. So those were kind of the open questions in our mind. But it seemed like there was like at least a good enough bet that, we wanted to try it out.
Yeah. And you had this agent reinforcement training framework, and you did the email agent. It's kind of like the first proof of concept. Was that obvious to do email? Was it obvious to call it that way? What was like the behind the scene? How should we package this?
So what I told our team, and we decided to go all in on RL in January of 2025. And we've been doing some experiments before that. We released before that kind of like an RL model that had, would generate like Hacker News titles from articles, which is a fun project. So we've done a little bit before that, but that was kind of like, we're like, hey, we're going to bet the company on, not in a literal sense, like we could have done something else later, but like this is like the thing that we're going to spend all of our time working on for at least a few months. And like what I told our team at that time in January 25 was like, there's probably like a 25% chance that this is the right direction, in the sense that like a year or 2 years from now, all the companies, everyone doing inference should be doing RL and task specific training so that like their models are just way, way better at their task. Is a relatively low chance, but it was sort of like one of those big if true things. Like if that is true, if it turns out that like just doing RL on your task is just like something everyone should be doing, and it's just, teaching these agents continually, teaching them through experience is just going to be a huge benefit, then like being the first people working on that would be a really, really like awesome position to be in. So that's how we thought about it, is like, less than 50% chance, but really big outcome if so. I think since that time, and I've been very transparent with this, like with our team and like when I'm talking to other people, like I don't think the chance that is the right approach is 100% yet. I think that we're still in the process, even after going through this and doing that, of like figuring out, but the probabilities in my mind are going in the right direction. Like now I think they're actually like, today, I was actually just thinking about this with another conversation. I think that the chances that like everyone should be, or everyone who's deploying an agent at scale should be doing RL with it, either as part of sort of like a like pre-deployment or even like continuously as it's deployed, that's like the pattern that's going to get to. I'd say there's like a 55-60% chance that that's just like the better thing to do, and that's informed by kind of like our experiments working with customers. So anyway, not 100%, but like going all the way back to your question, like, no, it was not obvious. It was an informed bet. It's still a bet, but one that I'm feeling pretty good about right now.
One thing I think that is tricky about just onboarding onto this space is all the math. I remember reading the DPO paper. I think they were at NeurIPS for 2023, and people were very excited about it. Some of it's like just being pretentious for a paper, but some of it's actually like real complexity. You don't have like a PhD, like a prior sort of ML background. How do you sort of come to grips with it? Like, what were the best ways to get around it for you?
I would probably push back on that a little bit. I don't think the math is actually that complicated. I think that like when you see the PPO equation or something with all the symbols, like if that's your first intro to it, then it feels very complicated. But I think like if you were to show that exact same equation, just like code, maybe not PyTorch code, because that you also have to like understand. But if you just like did the naive implementation in like Python and like showed someone like, hey, this is kind of like how we're computing the loss here, who was like a strong engineer, like I think it's actually like quite grokkable. So yeah, I mean, like I don't think it's like the barrier to entry is that high. I think you just have to like believe you can do it and then like spend some time staring at it. That would be what I would recommend is like, you can read the papers and look at the equation. I think actually this is one area where LLMs have been super helpful. If I'm reading a new paper and I look at one of those equations and I'm like, I don't understand how this new term they introduced like corresponds to like these other terms, then I can like dump like all the context around it into, GPT-5 and say like, hey, can you like write this out of Python for me and show me what they're doing differently? And that's super helpful for kind of like my background, I guess.
Yep. The way I put it is I wish that all these papers would just publish with pseudocode or Python, just straight up Python instead of math. Yeah. Because like you actually just need to look at the implementation.
Totally. I know like Jeremy Howard's been beating this drum for years and I mostly agree with him.
Well, I mean, there's a little website called Papers with Code and like people just keep not following it. I remember interviewing the DPO guys when they're at NeurIPS and it was just like, they were just very obsessed with like proving in principle equivalence to PPO. And like, it was very hard to follow. I'll definitely say that. And I think like now, obviously at some point, like GRPO kind of took over the general consensus. It was very strange because I think when DeepSeek first like started talking about it, it was viewed as an optimization. They tend to just generally couch everything as an optimization. But I think like the later insight, which I think you touched on in one of your blog posts, was that no, actually it makes comparisons independent rather than global. And like that's actually what unlocks some amount of like sort of self-supervised RL.
Mm-hmm. Yeah, I mean, it's interesting. There's real pros and cons if you're moving from PPO or something similar to it to GRPO. There are some big pros. I mean, one pro is just sort of like operational simplicity. Like there's a whole extra model you need for this value model you need for PPO that you can throw away with GRPO. And that just like makes your life easier. You don't have to train that model, but also like there's like no hyperparameters around that model that you have to configure. So that's nice. Another thing is the benefit that you're talking about, which we've observed. So the way GRPO works is you have to do like, a set of different trajectories or set of different rollouts all in parallel with the exact same environment, the exact same conditions, and then you score each of them. And GRPO uses the differences in those scores to promote the trajectories that did better and sort of like decrease the probability of the ones that did worse. Because they do it in sort of a group relative way, it lets you be a little bit looser with how you score them potentially. Like you don't have to necessarily have a globally aware scoring function. You just need some scoring function that is able to distinguish between this small set of things you have in front of you. And that's easier. That's easier for a human. If you tell a human choose which of these is better, it's easier for them to do than say like, is this one good or bad in absolute terms? Yeah. So that's nice. The big downside, the huge downside of GRPO, and I think actually the reason why GRPO actually is likely to be a dead end, and we probably will not continue using it indefinitely. The fact that you need to have these parallel rollouts in order to train on it is actually that makes the data generation much more complicated because you need a fully reproducible environment to be able to do these sort of parallel rollouts. And it turns out in practice, that's like getting that set up is the hardest challenge today with getting RL working is like actually designing this robust reusable, environment that you can run all of this training in. Most companies, and that's not true. Like sometimes that's easy to do. Like there's certain situations where you can do that. But for the work we do, at least, where we're training agents on real code bases to like operate real applications, it turns out it's like really, really hard to sandbox those things in a way that's like totally reproducible. And PPO, now in practice, a lot of times when you're training with PPO, you also will use an environment like that because it lets you do a bunch of runs and be more data efficient. But at least in principle, you have the option with PPO. You can actually like purely train on like, say, real production traces of like real people interacting with your app. And so you don't have to have a simulated environment at all, which makes the deployment like much easier.
Can you double click on why it's hard to do the sandboxing? Because in principle, we just capture all the inputs. Yeah.
Well, you don't need to just capture all the inputs. You need a system that reacts the same way your production system does. And in many different ways. And so let's say your Airbnb, right? And I'm bringing this up because this is like an example of one that companies have gone out and built sandboxes. Like if you're Airbnb and you're trying to you want to train an agent to maybe you're not Airbnb, fine. You're a company like us that's trying to train an agent to do really well at operating Airbnb and booking on your behalf, right? Like you have to build a copy of the Airbnb website that reacts to you as the user the exact same way that the real one does, with the same failure modes, right? Because if you don't include the same failure modes and bugs they have, then like when one of those bugs comes up in production, your agent's going to have no idea what to do with it. It's just going to fall over. You also need to simulate if this is like a sort of cooperative agent, right, where it's getting human input as well and kind of like working with the human to get something done, which in practice is the way a lot of these are deployed. You also need to simulate the user. And I mean, you can do the naive thing and just say, oh, we're going to have a separate LLM that, you know, with a system prompt that is like the user simulator. And we do that, but it's like, okay, but like the breadth of ways a user might respond, there's like a lot more diversity in that than the actual diversity you'll get in practice when you have this like simulated user. And so then it's like, okay, well, is this environment close enough to how a real user would interact that like, you know, if a user says something different, that it's going to know what to do? And the answer in many cases is no. If you're just purely training on kind of like an LLM user simulator, it's going to have its own idea of like what the correct way to answer is, and the breadth of like a way a human might respond in this situation is wider, and your agent just may not be able to deal with that.
Do you feel like it's hard to build the simulations as a company that needs to build the product that lets everybody do it? Or do you feel like even for the individual companies that own the code base, that are like domain experts in their own product, it's still just like a very hard infrastructure problem?
I think it's still very hard. You know, like ideally all companies should have this anyway, because they're, you know, if you're doing end-to-end testing, like theoretically, if you're following best practices, you would have one of those set up. When we talk to enterprises, almost universally, that's like not something that really exists. So there are some startups, like there's some companies we talk to that do have it, and we can just like use that, but it's a very, very small number that actually have an environment like that. And I think it's hard to do. And like there's lots of like weird bugs that don't show up in an environment like that. And even if they do have a testing environment, they don't have it populated with like full realistic data, which is also like important so that it understands how to, you know, interact. So I think in practice, it's hard in both cases. Maybe it's easier for the company, but at the same time, depending on, you know, the quality of the company's engineers, it might not be easy for them either.
Yeah. How do you classify the types of environments? So you have formal environments like a compiler, you know, you can put in there. It's like you don't need to do any work. They just work. Then you have this kind of like RL environment startups in a way that are building a bank environment. They're building these things that are not digital twins or whatever term of like the actual environments, but they're like close to it. Mm-hmm. And then on top of it, you have helping people trying to build the exact replica of their thing. There's obviously value in like the formally verified ones. We verified that. Do you think there's value in this like RL environment startups that are building like somewhat generic but task specific environments? And then if none of those work, then what do we do instead of GRPO? I guess the question.
Yeah, I suspect there is value in that. You know, I think the folks buying those environments and training on them in the big labs would have the best knowledge on how well they work. I think they probably work okay. I think they probably also are like, you know, and we'll see maybe with the next generation of models released, like how well they transfer. I would say so far, it seems like they don't train well enough. Like if you use, OpenAI's agent interface, it's like okay. Or if you use the computer use products that everybody's putting out, they're like okay, but like not reliable enough to like actually like let go do something interesting unsupervised in the world. And I think if the environments they were training in were high enough fidelity, then they would be good enough. In the same way that like coding agents can go much further, because I think that in that case we do have environments that are much higher fidelity because it's a much simpler environment in a lot of ways. It's like it's a code base. It's like maybe running a web browser. Like it's much easier to capture the full realistic environment in that context.
For those who are interested, when you make a reference to RL environment startups selling to the big labs, they're selling it for a lot of money.
Yeah.
Like at least 7 figures, right? Like,
That's my understanding. Yeah. I don't know. I'm not a buyer.
Please drop data points, because like people who are not in Silicon Valley don't know this. Mm-hmm. And like it's like probably the current thing in VC, which is RL environment startups. Anyway, a
lot of them.
There's like 20 of them apparently.
Yeah, mm-hmm. But it's like a small number. I know that all the labs are buying ad hoc, but in a way, it's almost like they don't even care. It's not a product. It's like they're basically like paying the company to build an environment ad hoc for them.
It's a very services business at the moment.
Services business,
exactly. But I mean, if you're spending like $1 billion in a training
but like
run,
you can specialize in like we are the one that does e-commerce. Like we are the e-commerce experts. So come to us for e-commerce.
Yeah.
Go to the other guys for like social media. Go to the other guys for like, I don't know.
But I'm curious, your take is like, how do you need to get the data out to make it fit in your training run. Especially when you get to like these larger labs, I think they have like very sophisticated post-training pipelines. And I don't know if there's like a way to just build a company where it's like you just send them a CSV of like data. It needs to be very integrated in it. But I'm curious what you've seen working with customers too.
So for RL, like the whole way this works is it has to sort of be getting feedback from the real environment. So I don't see a world where it's as simple as like, hey, you can, there's like a CSV type approach. I guess you could code anything as a CSV, but if you try hard enough. For RL to work, you have to be looking at real runs, ideally of your actual agent in its current state across within an environment as real as possible. So you have to like look at actually, and like the data format's like actually super simple. Like it's just like basically a list of, like chat completion messages. It's effectively whatever
tool calls.
Yeah, exactly. Yeah. It's whatever your agent will be seeing and doing when it's running. So getting the data is not hard, but what's hard is like, when you're doing one of these runs and your agent makes a tool call, okay, now that tool call has to connect, somehow it's got to get data back from something, and that data has to look like it will look in real usage. So setting up that whole part of the system is the challenge.
And then for just a reference drop for more people, Web Arena is my first instance of this kind of thing where you literally have a Docker container that has like a clone of Reddit, a clone of Wikipedia, a clone of GitLab, clone of CMS, and a clone of an e-commerce place. And I think since then there's like Mind2Web, maybe. I don't know if there's other large, well-known academic environments where people are basically using these as benchmarks, but probably also it's pretty useful for training.
Yeah.
So if you want to check out those things, you can definitely check there. I think the question for you is, as someone who bet on SFT, then you bet on RL, FT, and then now you see these guys making a lot of money, why didn't you go there?
It seems to me like that definitely is a services-heavy business at the moment, as it's presently constituted. I'm sure that these companies are all developing different kinds of secret sauce on like how to do this like more quickly. So that's part of it. I don't particularly enjoy services businesses, but I also kind of feel like we will move towards a world where either the big labs, like it's one of those businesses where like the only customers right now are like whatever 4 big, maybe 6 big labs that like are training these models on environments, and I don't think I'm a little
right.
skeptical.
What's the TAM?
Yeah, but like look, you say the same about Scale AI and all of their competitors that are like many billion-dollar companies that have basically the exact same customer set. So yeah. It may work out.
Yeah. Alessio, I don't know if you want to do a small shameless plug for Varus.
Oh, yeah. I mean, so Varus, one of our portfolio companies, they work with the people building the agents, not with the model, on like their internal tool call loop. So they can observe all the internal traces and build the data to then have like a OpenPipe do the RFT on the thing. I think in the enterprise, we've seen a lot of that, especially for chatbots. It's like the less sexy use case, but like they work with a lot of financial services company where their customers go in there and it's like, what's my balance? Like, when did I do this transaction? And those are all tool calls, and they need a way to test and improve that behavior. And the models haven't gotten that much better because these tools are like badly documented. They're like badly named. I think that's kind of like the problem with a lot of the agent builders that are not AI native companies is like, they just put this like very generic tools in the thing and then they expect it to work like magic. And these simulations kind of help them also have the usual compliance things. It's like, before shipping this, we tested that it doesn't give financial advice. We tested that, there's all these different things. So I'm curious to see how much the companies generalize. I think like Varus has a lot of success in like highly regulated environments because they have different requirements. But I'm curious if you have a different way to segment the market of like, when you think about RL, there's like environments that are like low stakes. There's like environment that are like high stakes. There's environment that have implicit rules that are made by the SEC or other government agencies. How do you think about it?
Yeah, I don't know that segmentation is necessarily the most relevant. I'd have to think more about that segmentation, whether it's that there's like a strong difference in how useful RL is across those sectors. Where I see the segmentation is something basically just like capabilities based, where it's like, hey, if I'm trying to do something that's like much more advanced and maybe like long horizon, then RL can probably give me a much better behavior. And I might almost think that like, yeah, those sort of like more compliance, like I feel like in those kind of environments, you probably don't want your agent doing very much because then it's like you can't make any guarantees about what it might do. And so you're probably not doing these long horizon things, and maybe RL is not going to get you what you want. But I don't know. Yeah, I haven't thought about it too much.
Yeah, I think like a lot of the customers don't necessarily end up doing RL anyway. Mm-hmm. It's almost like the simulation and the environment is like a way for them to understand the paths that the agent can take, and less about we need to then use that data to do fine tuning. But I think it's like it's going to be a spectrum. You know?
Yeah.
What replaces GRPO?
Yeah, it's a good question.
We need the alpha.
Yeah, I mean, I don't know is the short answer. I do think this is like a fairly high salience question in the research community. I think there's a lot of folks like trying to figure that out.
Every paper has a variant. Like,
but I think, the big question is like, are we doing, normalization based on grouping or in some other way, right? That's like, I would say, like, I would claim we're just going to keep calling it GRPO as long as the normalization is done within like a group, even though, there's a lot of things that like probably should get their own names. A lot of things that have tried to get their own names and have failed on the marketing side.
Yeah.
I think something that like doesn't require group level normalization, which a lot of, older things didn't, probably works, but I think that the older things also are really finicky. So there may be other kinds of simplification, and I don't know exactly what those will be.
Where do you put the prompt optimization thing? We did a Dev Day episode and we mentioned GEPA, and then everybody came out of the woodwork on Twitter.
DSPi bros.
About it. Yeah, exactly.
No, okay, tell me, have you or people you talked to tried GEPA? I want to know like what.
I read the paper. Okay. I'm just like, look, like the prompt layer updates are not the same as weights updates, which they're just comparing apples and oranges. And I talked with a few people I respect on the RL side, and they kind of validated like the way that these grad students market their papers is their thing beats the current hot thing, and the current hot thing is GRPO. But like they're just not that comparable.
I disagree with that. Like I actually think they are comparable in the sense that like it depends on for what purpose, right? But like if I'm a company and trying to like get the best performance out of my agent, like I don't care if you're changing my prompt or if you're changing my weights. If you get better performance on my agent, I'm happy. On that front, I do think they're comparable. And we evaluated like
so their answer was you are going to do both. If you really want max performance, you're going to do both.
Yeah. We evaluated everything from DISP, and we evaluated GEPA as well. And it's like, it just doesn't work. Okay. That's going to be the
fighting
the
words.
Quote. Yeah.
GEPA doesn't work.
It didn't work on the problems we tried it on. It just didn't. It got like a minor boost over the sort of like more naive prompt we had, and was just like, it was like, okay, just kind of like our naive prompt with our model gets maybe like 50% on this benchmark, and like GEPA got to 56, and we do RL and we get to like 96. I mean, it was just like not even comparable. And so maybe we were holding it wrong.
But you see, both sides are claiming skill issue, right? So what they would say is you probably used it wrong. And then
That's fair, yeah.
RL people are saying like probably GEPA guys, when they set up the GRPO benchmark, it wasn't a very fair comparison, which is exactly what my source said. It's hard to tell. Everyone is trying to get to some version of the truth.
Yeah. But what I will say is like we want it. I mean, I don't know if I would say go so far as to say we want it to work, but we certainly want to know if it works. Like that's like actually very relevant to like the product.
Yeah, and if it's more efficient to get there,
and
then
we just haven't been able to get it working.
It's actually kind of more credible now that you're like, you're part of a larger CoreWeave, that you're not, obviously, because I think GEPA maybe makes OpenPipe like less relevant.
I totally would disagree with that.
Okay.
Because like the level we see ourselves operating at is actually, we're not like RL bros trying to figure out like the use case for all RL. We're like, hey, we're working with all these enterprises, with all these big companies we're talking to, and we're trying to figure out like how we make their stuff work better. And so like I personally am very motivated. Like if something like GEPA works, like, okay, let's build a product around that. That's how I think about OpenPipe, at least.
No, I mean, that's a good clarification to make. Even more so, you actually took a sincere look at it and you concluded that there was nothing to do, nothing to build.
Well, maybe we were holding it wrong.
So we had Shen-Yu on the podcast a while ago, and like I think he's been a proponent of automatic prompt optimization and this idea that like you can do a lot more in the prompts than you can do in the weights. And in principle, I'm inclined to believe that something like a DSPi, something like a GEPA works. So I'm very surprised to hear this.
Yeah, like we keep trying it, Yeah. We tried the MIPRO V2 stuff that was hyped before that.
Also, okay, I should not bury the lead on the best argument for this, which is it basically GEPA models how the big labs do their system prompts. It's genetic evolution, and they just sort of incrementally evolve based on like the overall evals that they have. It's slow because it's done by humans, but GEPA theoretically improves it. It automates this.
Okay, well, hold on. Is the kind of the big labs have something? This is news to me.
No. This is philosophically the same. I'm not saying like.
Oh, sure, but like. You're injecting a whole lot of human intuition and kind of like potentially out of band information.
We have the best model in the world, which is humanity, or like smart humans. And now we're doing GEPA using dumb LLMs.
Right. But they're also like the humans can bring in out of band information that like maybe is not captured in the actual like, the eval. Like they can be like, oh, yes, technically this did well on the eval, but it's like not really, like I would suspect that a lot of that ends up getting injected through that human being in the loop.
Yeah. I've always been very surprised at how these guys work on their system prompts, which are tens of thousands of words long, and there's no ablations. They just kind of pick what seems to work and then chuck it in there. And that is the Claude system prompt.
Can't argue with success.
Is GPT-5 the first model that had a prompt optimizer by one of the large labs? I believe so, but I don't remember.
Claude Workbench had this like a year and a half ago, if you see it that way. It just wasn't like fully automated, but it was extremely good for its time. I kept telling people about it. Nobody believed me.
Do we know if they used it internally?
Claude Workbench? Yeah.
Okay.
Why not?
Oh, I don't know. Like I just, my experience, knowing a lot of people at these labs is like they launch a lot of products because like some team is super excited about this product, but that, I wouldn't put that much weight on it just because they launched it.
For some measure of use internally, I'm sure people I talk to are biased. I don't know if you fully explored that thread.
No, I think that's it's just interesting that now it's been acknowledged that like the LLM can improve your prompt. And so I think like GEPA now is also riding this wave of like, okay, maybe we can do this programmatically, but I also think the long tail of people just prompts really badly. And so I think there's some value there versus once you go into RL, you already have like a more sophisticated audience, like who gets to do GRPO? People that are really smart. Who gets to do prompt optimization? Like everybody's trying to do it. So
yeah, that's fair. Maybe our baseline was
I know your naive prompt is probably like, top 10 percentile of prompts that people put in these LLMs.
Sure, I'll take it.
Yeah.
And then the other thing that comes to mind as you were talking about injecting things out of band and all that, I think there's a broader trend that I'm tracking for World's Fair 26, which is the move to online evals. The way that we do evals today is probably too locked down. You're kind of fighting the war that you already know should be fought, and you're not fighting the wars that you don't know about because you didn't plan for it, whatever. How can we sort of move more online evals into our GEPA process? And maybe that's what it is.
That part I'm much more bullish on. And we can make the analogy, like we can pull in kind of like RL intuition here, which is if you're doing GEPA on a sort of static data set of like, oh, this is the input, this is like what makes a good or bad output, then like as you're updating your prompt, like your information, the data you're training on becomes less useful, right? Because it's generated by, because it's based on kind of like the problems you were running into before. And that's the same problem you have with RL, where you have this concept of being off policy, where it's like as you're doing training, you really want to be training on rollouts that came from the latest version of your model. Because if you train on some that came from further back, then it's like it's sort of stale data, and it's like it's no longer representing the current issues with your model. And so if you try and correct for the issues that existed back then, it may not actually be helping you that much. And I think, for either RL or prompt optimization, that's definitely true. I think that like one way to apply that in practice is exactly what you're saying, where you're using the actual data from your real evals. You have some way of saying like, hey, either people flagging these or an LLM flagging these, or some way of saying like, this was a good or bad output. I totally agree with you that like, if you're bringing that into your process, I'm like much more optimistic that you're going to get good results.
Yeah. And the pipelines are not set up. This is like analytics and UX people like being drawn into the ML process, which they've never been done before. If I had to make a bet as a big theme for next year, this is going to be it.
No, I agree. And I mean, I think that like all of the sort of observability people, like platforms, see that and like are trying to figure out what the right shape is. I haven't seen the right shape yet, but yes, it seems like a theme for next year.
StatSig.
Maybe. Yeah. I haven't used them, but OpenAI seems to like them.
Yeah. I mean, I do think like buying, an experimentation platform makes sense. And like, I think it's sort of like I've said before on the podcast, I think that I'm very bullish on model routing as a feature, but less bullish on model routing companies because of exactly stuff like this, where like it is just going to get absorbed into the model. It's a very big part of building the process. You probably don't want to. And it's not that hard. Like it's not rocket science. You're just like connecting pipes and making sure things are set up so that it's easy to use that data.
I have a question for you, a general question. So what fraction of tokens generated by, say, like the end of 2026 do you think are going to come from open source models versus proprietary models?
Oh, that's a fun question. So we have an answer from Ankur from Free Interest where he was like, it's 5% and going down. I think it's going to go up because of the amount of enterprise adoption of open models that I'm seeing. And also,
because there's a lot of demand. Like the enterprises would much rather be on open models if they actually could get the performance they're looking for.
Yeah, for cost, for privacy, all that stuff. And I think like basically, honestly, it's just literally like we may have hit quote unquote AGI in a sense of like it is the average LLM is capable of the work of the average human, not the best human, but the average human, sure. Like it's actually pretty decent at customer service. Like and it's actually pretty decent in like, I don't know, transcribing things from PDFs, whatever. So like, yeah, I mean, totally. I think that should rise, but people who believe that it should rise to like 50% are out of their minds.
And I think it's a trick question. We should take coding out. I think once you take coding out, I think, it can be like 15, 20%. But I think with coding, it's still going to be very low because like these max plans are like so subsidized and so many tokens are being generated. Like Anthropic is like, 50% of the revenue.
Is your claim that it'll mostly be, that coding will mostly be closed models because the tokens are subsidized or because the models are just so much better that
I think as long as,
anyway?
I mean, I'm paying $200 a month and it's like I'm spending thousands of dollars. Like by accident, I paid with like my credit card and I spent like $100 in like an hour. And it's like,
by the way, this is like the thing that nobody wants to talk about for Anthropic. Like Anthropic went from like 1 billion in revenue to 5 billion and everyone's like, ooh, yay. And then like, what's the margins? You have this like goose meme going like, what's the margins? They say it's like 6%. You are part of the 6% that is abusing everything for everyone else.
I'm not abusing.
You're the loss leader.
It's not like I'm rotating accounts. I'm just using the one that I paid for. It's like...
But like through you, people like hear about Cloud Code, they pay the $200 a month and then they don't use it and they pay for your inference.
Yeah, thank you. Thank you, everyone. Keep doing it.
Right?
I don't want it to go away. But I think like I don't really see... It's hard to see a world in which Quencoder or whatever model replaces that. Because between quality and cost, it's like to generate this amount of tokens for $200 a month. I don't know how anybody can like offer like Together Fireworks. They cannot really offer it at that price, and the quality is not as good.
But the reason they can't offer at that price is because of the subsidies, right? Which is not like the long term like sustainable dynamic.
I mean, it's interesting because both Anthropic and OpenAI are building their own infra, right? And like they're gonna get to a place where they're gonna have idle GPUs that they own. And so they will also be incentivized to have 100% utilization. And so, they will subsidize some of it. Just the same way, if you go on SF Compute, like you pay $140 for like an H100 instead of like the $220 listed price on AWS. So I think it will continue, but again, it depends on whether or not they actually have the 500 billion like they were saying, which I think they do. Just to be clear, I think Stargate will go online. But once it goes online, then it's like, well...
If they figure out how to pay for $500 billion worth of compute, then they probably can subsidize for a while.
I think they have the 500B. They're going bigger. Isn't it obvious?
What do you mean by have?
At the start of this year, when they announced Stargate, people were like, oh, you don't even have 10. Like Elon was like, you don't even have 10. Whatever. And then Satya's like, I'm good for my 80. But like now we're seeing all the money start coming in, and like probably it's in the order of like 200, 300 billion, like that you could probably get raised and committed, and they're going to get the rest. Like it's fine. Like I think that the plan is actually a lot bigger.
Can I just say I love this industry. It's like, yeah, they've got like 200 or 300 billion, and like what's another couple hundred billion? There's no other industry in the history of the world where you can say,
it is stupid, but like also like, do you doubt it? Like I don't.
That's fair. Yeah.
No, like I literally like after last week, I think maybe 2 weeks ago with the whole Oracle, NVIDIA, and then even AMD deal, I'm like, oh, like these guys not only they've locked down Stargate 1, they're working on Stargate 2, whatever that is. And like the sheer ambition is like freaking crazy. There is still one more shoe to drop, which is the non-sovereign wealth funding that OpenAI needs to get, which they've promised to drop by the end of this year. And my money is on they have to do a coin. Like I'm not a crypto guy at all, but like, you know,
you think this is going to be like an OpenAI coin?
This is the one AI founder that has his own coin already.
Yeah.
And like he needs more money. And he said that they will come up with new innovative financing methods. What else is there?
Yeah, I mean,
they're already in the token selling business. Like,
but you got that's a great line.
Buy an OpenAI token, it translates to a GPT-5 token. Like, sure,
it's a stable coin.
You'd have to get a lot of political buy-in, I think, to take that level of risk.
The White House that is most crypto friendly since the dawn of time.
Well, and I guess like Elon's out of there now, so maybe they can get make the friends. Yeah,
I think it's doable. We'll see. Yeah. You know, like who knows? I for what it's worth, nobody's like this is a me theory. I don't have any inside information. Should we go back to Ruler?
Yeah, sorry. Right, OpenPipe. Anyways, we were saying. I think this story takes us to July 25 when you release Ruler, which you call easy mode for RL rewards. And then, I mean, shortly after you get acquired in September. So maybe you just want to talk through the summer, you know, what was the vision, then maybe how the acquisition came together. Yeah,
absolutely. So, you know, I mentioned my initial like opinion of like how likely this direction was to work was maybe 25%. We're up to, 55% or so. And Ruler is actually a big update that got me from the 25 to the 50. So let me, I guess just for context there. So basically, there are several problems you have to solve if you want to use RL successfully. The problems you have to solve, I mean, some of them are just like really dumb, basic, like, hey, you got to get the infra, and like the libraries have all really sucked and been built by, PhD students who don't know like how to build reliable software. So like there's like all these like practical issues that we're working through. So that's one thing. And that's kind of what we're trying to solve with Art. But even after you've got that solved, you've got like major issues, which is like you got to know if your agent is actually, or whatever system you're using on RL is doing a good job, right? That's fundamental. You have to have a reward. You have to know it's doing well or poorly. Sometimes that's easy to do. If you're solving like a math problem or something, you can come up with a data set of math problems and the known solution and check if it's the same. On the coding side, there's been a lot of like innovative work around. I mean, there's first of all like a lot of open data and a lot of there's like I think the approach a lot of companies take is you find existing test cases and then you break them. But there's sort of like a way to figure out if you can run the test case, right, and see if your code fixes it or not. In a lot of other domains, it's like much more murky. It's like, what is a good job versus a bad job? How do I know if I did a good job? And you really need that information. So we've tried a bunch of different things. Ruler is a library that we released.
Which let me relative universal LLM elicited rewards.
Thank you. Yes. And the way it works is basically this depends on the sort of GRPO insight, which was mentioning earlier, that you actually don't, with GRPO, it has this nice property where you don't have to have like an absolute judge of the truth. You just have to judge relatively. And so simplifying it a lot, it's basically just LLM as judge on a whole group. So you say, okay, this is the task I'm trying to achieve. Here's 4 different runs of an agent trying to achieve it. Which of these did best? And it stack ranks them. And it turns out that works phenomenally well with GRPO, like way better than I expected, way better than, anyone who kind of like I talked to before we actually tried this expected, because it's sort of in the LLM using as judge, it can sort of like self-ground because it's just getting these relative ranks, right? So it doesn't have to like have like an omniscient view of like what good or bad looks like. So that has worked at basically everything we threw it at. We've done it with a bunch of client projects. We've done a bunch of our own customers. It basically just works. Like it's basically like I honestly kind of feel like the reward assignment problem is like fairly solved. Yeah, it's fantastic.
Just any LLM as judge off the hook. Like
we've tried it with so many things. Like so one of the results we published was we used Qwen 2.5 14B as the model we're training, and as the judge we used Qwen 2.5 32B, which is like not, I mean, it's fine, but it's like it's much worse than any frontier model, right? And even with that combination, we were able to get our agent doing like state of the art better than any frontier model on the task we tried it on, even with like an extremely weak judge model. So it really doesn't depend on having like a really great judge model in practice. So yeah, it's just not something we've had to worry about since then at all. So that's kind of like checked off. So that's sort of like got me like a significant increase in like, okay, this is actually something people can apply. This is now something that's packaged up. People can just use we open sourced everything. You can use it off the shelf. if you stick it in your training run, it will probably just work. So that leaves the remaining problem, which we were talking about them out of order, but like that leaves the environment problem, right? That's like the one big remaining piece that like we don't know yet how to automate or remove, and requires a lot of manual work for every single task.
For listeners, this is why I kind of refer to it as self-supervised, because it is like removes more and more of the human judgment. And like the history of machine learning, all the way from like, I guess the start of like ImageNet and everything, it is really like that insight of like, you should just take humans increasingly out of it and scale up the data you can just throw in there with no supervision.
Yeah, totally.
Yeah, it's really awesome. Are you bullish on dedicated LLM as judge models? Have you looked at those? Bespoke Labs, we did an episode with them, and they're really trying to carve out a niche in there.
We've looked into it. We've trained some ourselves. We've also like used some off the shelf. There's an evaluation benchmark that the AI2 people put together. A reward bench, and so reward bench is kind of like trying to benchmark models on serving as LLM.
And reward models are LLM as judge in your mind is the same thing.
Yeah. They have
mildly different. Depends on the task. Like LLM as judged is usually more sort of product facing, and reward modeling is much more specific within like a chat task. Which is that used to be the old meaning of reward model.
I don't know. Maybe terminology has changed. Like I think they're pretty equivalent.
I understand that. Yeah, I can see your side.
Anyway, so yeah, reward bench is kind of like, and so we've tried a bunch off that. The thing is, like, I guess my maybe meta take on this is any task that is extremely common is going to end up in like as a specific like part of the training data for the frontier labs. And LLM as judge is just something everybody is doing in so many different contexts that you have to assume that all of the frontier labs have a bunch of like LLM as judge style tasks that they're training their models on. And I do believe that if something does kind of like make it in a like more than minor way into their training data, that like they're going to do at least as good a job as a dedicated model. So I don't think there's probably a lot of alpha in dedicated LLM as judges, just because it's something that like let me caveat that and say, like, if you've got like a very, very specific task that's like weird and has weird requirements, and you have a lot of data on what's good or bad, then like training a reward model for your specific task, I think could still work. Or, fine tuning an LLM as judge on your specific task could work. I'm pretty bearish on like hey, this is a model that is trained as an LLM as judge, but it's a generic LLM as judge that can be used to judge anything. I just don't think you're going to beat the frontier labs on that.
Yeah. One other version of this that is not quite an LLM, but some people are thinking about it, is something that we're working on for a future episode, which is world models.
Sexy.
Very sexy. First applied in video, as far as I can tell, for Genie 3, Genie 1, 2, 3, and now with code, and potentially with virtual cells for AI bio. Any exploration there that's interesting to you?
Yeah. So we've been playing around with it a little bit. It's one of the directions that I'm like fairly optimistic on for solving the environment problem specifically. Because if you think about it, like a world model, it's a simulated environment. That's like what its whole purpose, right? So if you get one that's
in an LLM like thing, not like a Docker.
Yes. Yeah. So it's like, whatever, hallucinating, generating, imagining the responses you'll get from the world. So you can imagine, right, if you had like a really, really great world model that you were training on, it's like your agent that you're using, it would go out and make some tool call, and then this world model would generate, hey, this is like probably what the tool call. And if you have a smart enough, strong enough one, then it could keep its own, effective internal state of like the changes you made so far and how that affects. So we've played around with it some. I think if we can get it to work really well, then that could be a solution for the environment problem, where you just take a bunch of production traces and use those to condition your world model so it understands your specific system and what its failure modes are, and then train against that world model. And it works, and the resultant, agent that you train with that would then be able to perform in your real environment. So I do think it's like a really interesting area of research.
Yeah, and did you see the Meta cold world model work?
I don't think I saw that one.
Okay, yeah, it was like 2 weeks ago. We've just confirmed that the guy for AIU code in November, and it's really interesting. Like the world model is.
Sorry, you're talking about the Meta one?
Yeah.
Oh, okay, I missed. Yes, I did. I saw that one.
I said a lot of syllables, so it may not have parsed, but like it's literally like having a debugger as the environment, as the world model, and opening up the execution trace to the model to see what's going on and see the state and track the state as the code executes. Seems to be smart and exploits the unique situation of code environments where we can actually do these things.
Mm-hmm. Yeah, I think the way they envision that model being used is a little different. Like, I think they're trying. It's actually, I'm curious. I'll have to see the talk. But my understanding from that paper is like the goal they're imagining is this is almost sort of like a pre-training step, and then now that this model understands code really, really well, we can then use it as basically like a code generation or a coding agent of some kind. Okay, yeah, which I think makes sense. That's almost more like a different kind of pre-training, I would say. The way I'm interested in applying world models is it's basically as its own end, right? Where it's like, actually, the goal is to come out of this with something that simulates the world, which is not something you really need in code at all, because it's so easy to like run code, and you don't need to model what will happen if you execute this code typically, because you can just execute the code and see what happens,
right,
for training purposes.
But it closely models how we think about code when we code.
Yeah.
Is we kind of mentally execute the model as we type, and we go like, is that what we really want? Yeah, I don't know. Anyway, it's the first model that Meta's released since the MSL reorganization. We know, just based on our context, that they're very, very, very interested in code models as a path to AGI, which I'm also, of course, very interested in.
Totally.
I know we kept you in here for a while. Let's wrap up on the acquisition. So a lot of people say, companies are not sold, they're bought. What was that process like for you? Did it just happen? Like, what was the behind the scenes?
Yeah, so that was driven by actually mostly the Weights and Biases founding team.
Lucas?
Yeah. So yeah, Lucas and Sean particularly. So they, had recently been acquired by CoreWeave, and CoreWeave was looking to, continue growing up the stack. And so, yeah, they approached me and were like, hey, no pressure, but like, this is like an area that we think is really promising, and we, would you like to work here? And so that's how the conversation started. It was long. It was pretty painful. There were points as late as like the week before we actually signed, where it was like unclear if it was actually going to happen. So that part was super painful. However, we've been there a month now. We just shipped a product yesterday, which I'm super excited about. It's been fantastic working there so far. Like, I was like very concerned. I was like, okay, yes, this is great. We make a lot of money by selling our company, but like, is the work environment going to like really, really suck? And I was like, well, I guess that's just a risk we'll have to take. It's been fantastic. Like, it's honestly been way, way better than I could have imagined.
Do you go down to the office, like the one down here?
I was there today. We work for, so I'm based in Seattle. So they have a small office up there that we work for.
Weights and Biases office in San Francisco is fantastic. If you have the chance, go visit. They do a lot of hackathons and co-working things.
Yeah, there's a hackathon going on in a month or so.
Every week there's a hackathon. But yeah, I mean, so do you consider yourself working for Weights and Biases or CoreWeave? Or both?
And OpenPipe too. No, no. Yeah, it's I report to the Weights and Biases founders. So we're within that organization. In the org chart, we're there. I don't know. Like, branding wise, they're trying to say everything kind of that's not being sold to like big labs is kind of Weights and Biases. So like our stuff we're launching is Weights and Biases branded.
Yeah,
it's not not CoreWeave branded as much. I don't know. It's still like they're still figuring it out.
And what's the product you launched?
We launched serverless reinforcement learning. Basically, it lets you offload all of the GPU management. You don't have to worry about crashes and out of memories and scaling up and down. We handle all that for you, and you just define your environment, you define your reward function, and then you just every time you run a step, you kind of ship back to our backend. Hey, these are the trajectories, these are the rewards. Now update my model, and we just make it work for you. It makes it way easier.
Yeah. Okay. Very thinky.
It is very thinky-like. I love the thinking machines launch. I think they have a really good idea. It's also very validating.
How did this take so long to appear? It seems like...
I don't know. Yeah, we were... But I felt this way about everything. There's so many things that should exist, clearly. I just think there's still not enough people, smart people working in this space. Honestly, we need, I realize that there's a lot of people. It just feels like there's still a lot of low-hanging fruit nobody's doing.
Okay. One thing I saw from your post was your North Star as the RL team at CoreWeave is to build a world where every agent learns continually from his real-world experience. So you're touching on the hot topic of the moment, continual learning. What else do we need to get there?
I super believe that. And that's basically the vision where I'm I keep talking about these percentages, 25, 50. If we get to the world where we build that, then I think it's just the advantages are huge. They're clear. Everyone should just deploy their agents that way. We want to be the team that builds the software that makes that easy to do. So I talk to a lot of engineers at our customers, and they're trying to deploy agents. And it's so easy to get the initial prototype and something that kind of works well. It is so hard to get from that to something that you are confident is reliable enough to actually deploy in production. And when you actually look at what those failure modes look like, it's like, oh yeah, like we know if it gets in this situation or if it gets like these kind of like inputs, like it behaves funnily, but then it's like, yeah, you can update your prompt to address that, but like that's not scalable because at a certain point it's like going to start breaking other things. You know, you don't know what it's breaking. You really want some way to just like say, okay, look, this thing you did there, that was the wrong thing. Just like adjust this behavior when you get in this, and then, you know, otherwise carry on, right? And that's what we can do with RL. And that's what we can do with continual learning is like, we don't have to like have this concept of like, oh, up front, I'm like trying to make the perfect model that solves everything. It's like, I'm trying to make a model that's good enough. I can deploy it in production. And then when these errors come in, I'm going to say, oh, you know, exactly this. I mean, very analogous to how you train a human employee. Like, be like, oh, no, actually, that's not what you should do in that situation. All right, fix that and carry on. And that's just going to make this whole process so much easier. And I think that, you know, like, I think that there is today, like 10 times as much AI inference that could exist than is existing right now, just purely with projects that are like sitting in the proof of concept stage and have not been deployed. Because there's like huge bucket of those. And it's all about this kind of like reliability issue where it's like, okay, like it works in controlled circumstances. There's areas where it doesn't work. And so if we can solve this problem, there's that like 90% of the like inference market, like addressable market today, that's just going to like come online because we've solved that problem. So that's what we want to do. I'm super excited about it. And like, I think we have very concrete ideas on like the specific pieces we need to make that work. And we just have to execute against them.
Do you feel like the online RL is more susceptible to like the reward hacking? Especially as you're like shortening this loop and like you don't spend as much time like looking at the different checkpoints.
I'm not that worried about it. And the reason why is because reward hacking is quite easy to detect once it starts happening, because once the model's found some hack, it just starts like doing it all the time. It's like, oh yes, this worked great. I'm just going to keep doing it. And so you like notice very quickly, whoa, it's doing this thing. And assuming you're using at least in part an LLM as judge to like determine which ones are good and bad, it's so easy to just throw in an extra term and be like, hey, that like weird thing that you keep doing, like if it does that, like that's bad, give it a low reward. So we've done this with a bunch of customers, and like reward hacking does happen, but like you just see it and you like adjust your, you know, reward prompt and it just goes away.
What's a thing from YC that guided you through your entrepreneurship journey? And what's one thing that maybe you like find that you disagree with YC on?
Oh, that's a good question. One thing that I really identify with, and I've tried to do a good job, is kind of like, you know, sort of, I think they say like, hold your problem tight and your solution loosely, right? Where it's like...
That's what you did?
Yeah. Spend a lot of time thinking about what is the problem people are trying to solve. And then it's like, don't be too bought into like the way you're solving it today. I think that's super important. Everyone, you know, it's very easy to get that balance wrong if you're not thinking about it very consciously. That's something I disagree with. That's a good question. I think there's lots of things I disagree with, but I don't have it like cached in that direction in my brain. I don't know. Like I definitely have disagreed with lots of specific pieces of advice, but yeah, I don't have like a great answer right now.
I'll bridge it for you in case something comes up. Sam Altman's like, you know, everything I said as president of YC was wrong for OpenAI, right? Like, do B2B, ended up doing B2C. You know, you should ship like products often, like ended up being stealth for 3 years. Like,
yeah. Yeah. Actually, I think that second one does resonate with me a lot. Like, we have tried to ship really quickly and just kind of like, sort of like follow the gradient of the market. I think if I do another startup, like, and I don't know, maybe this is just me like being beat up by the market too much. If I do another startup, like I would like, I think at least some points I probably would have done better to be like heads down and execute on my vision for longer and like kind of like go for the more ambitious thing, but that would take longer to sort of like prove value, which is definitely not the YC way. But I think if you have like, I don't know, a good vision and good taste, then like that can like work quite well.
Yeah, we'll see what that is whenever that comes out. But thanks for your time. This is a great overview of everything.
Thank you, guys.
This has been a super fun conversation. Thanks to both of you.
Awesome.